Okay, today we're going to talk about density. What in the world is density? Well, it's real tempting to say it's how heavy something is, but that's not correct. Let's think of what would happen if you had a gallon of milk and then you had a little rock, a pebble. The gallon of milk is heavier than the little rock, but the rock is actually denser than the gallon of milk, because if you put the rock into the gallon of milk, the rock is going to sink. So it's not actually how heavy something is, right? So if we think of a bunch of pebbles and we think of some water and we think of a ping pong ball, what's going to happen if I put the pebble in the water? Well, certainly it's going to sink. Why? Because it's denser. What's going to happen to the ping pong ball? It's going to float, of course, because it's denser. But why? What exactly is density? Well, density is mass divided by volume. So we were kind of sort of right when we talked about how heavy something is. But when we talk about it, we have to say how heavy is a certain amount of the material that we're working with. So if we're going to compare some water and we're going to compare a pebble, we have to take the same amount of the water and the same amount of the pebble and see which one is heavier for that particular volume. That is what we're focused on. So we have to look not only at the mass of the thing that we want, but also at the volume. Now, we tend to measure mass in grams, and we tend to measure volume in cubic centimeters. If you remember, a cubic centimeter is about, a centimeter is about how long or how wide your little fingernail is, and so we're just going to make a little box out of things that are that size. Okay, so let's say that I have a particular metal, and its density is 1.4 grams for every cubic centimeter of the metal that we have. So if I have 1 cubic centimeter of the metal, if I have 1 cubic centimeter, it must weigh 1.4 grams. But if I have 3 cubic centimeters of the metal, what must its mass be? What do you think? Well, sure, if 1 cubic centimeter weighs 1.4 grams, then 3 cubic centimeters, if we want to do it using cross multiplication, you can do that, or you can just use it using logic. 1.4 for 1, that would be 2.8 for 2, and it would be 4.2 for 3. So that would be our answer, 4.2 grams for 3 cubic centimeters. Since the density has remained constant, if the volume increases, what must happen to the mass? Well, let's look at that. The density remained constant. Our metal was always had a density of 1.4 grams per cubic centimeter. So the volume increased, and hence the mass increased. If the mass increases, the volume increases. Okay. Now, at a constant density, if I decrease the volume, meaning I have less of it, what happens to the mass? Well, the easiest way to do this, you sit here and you say, well, I don't know. What's it going to do? Well, play with numbers, right? If I have something that's a constant density, let's say that my density is 2, all right? And we're going to use some pretty simple numbers. So let's see, how do I get a density of 2? Well, let's say that I have a mass of 2 and a volume of 1, all right? So 2 is 2 over 1. So it says a constant density, my density is not changing. If I decrease the volume, so if I make the bottom number smaller, like 0.5, then I have to make the top number smaller so that I can keep my 2-to-1 ratio to make my density actually be 2. So if my volume decreases, my mass had to decrease as well. Let's look if I have equal volumes of 2 substances, and the mass of the second one is less than the mass of the first one. All right, well, again, we're sitting here conceptualizing. Don't do that. Actually go and use some numbers. Mass over volume. So that's my first one, and this is my second one. All right, and it says I have equal volumes of the 2 substances. Okay, well, let's say that's 1, because that's real easy to work with. And it says the mass of B is less than the mass of A. So let's say the mass of B is 2, and the mass of A is 4. What does that tell you about your densities? Well, your density of A has to be bigger than your density of B. Right? So my suggestion would be to actually plug numbers in and give it a shot. Let's try it again. If I have equal masses of two substances and the volume of B is less, let's say that I have a mass over here of 4 and a mass over here of 4, and the volume of B is less than the volume of A. Well, my density of the first one is going to be 1. My density of the second one is going to be 2. So B has to have a higher density. In other words, if we were dealing with B is like a rock, and it will sink in water. Okay. If I have a substance with a mass of 4.4 grams and a volume of 2 cubic centimeters, what's the density? Go ahead and pause the video. Give it a shot. See if you can do it. All right, my density is mass over volume. This is very straightforward. My mass is 4.4. My volume is 2, so my answer is going to be 2.2 grams per cubic centimeter. Try this one. Pause the video. Figure it out. All right, I look at the density, which is 3.2 grams per cubic centimeter, and the volume of my substance is 2, so then the question is, what number goes up here? Well, what number divided by 2 gives me 3.2? Well, that's 6.4. So my mass is going to be 6.4 grams. Right? All you're doing is plugging and chugging. How about this one? Give this a shot. Pause the video, figure it out. Don't wait for me to do it. Pause the video. Okay. I have a density of 1.5 grams per cubic centimeter. And the mass of my substance is, mass goes on top, 0.5 grams. So, what's the volume of the sample? Well, it has to be 1/3 of that number. Right? So that number is going to be exactly at what the number is going to be. It's going to be 0.5 divided by 1.5, which is 1/3, which is 0.333 repeating. Okay, so you obviously need to know the formula for density. You need to be able to calculate the value of any of the 3 variables, knowing the value of the other 2. You need to be able to predict the behavior of the variables given on information. So, for example, if I told you the density to remain constant, the mass goes up, what happens to the volume? You have to know that the volume goes up. You need to be able to, and guys, I don't suggest you memorize that. I suggest you figure it out every time. All right? There's a worksheet that you should do that will verify that you understand density before you come back and take your test. If you have any questions, feel free to find me either during class, before or after school, and I'll be happy to help you. Have a great day. See you in class.